Hey guys, so we are on Unit 3, Day 4, and we are doing even and odd functions again, but we're going to talk about them graphically. Yesterday we only looked at their table to see, in the calculator, to see if they had opposite inputs with the same outputs or opposite inputs with opposite outputs. Or opposite inputs with neither of those. And so we kind of classified them based on looking at the tables, whether they were even, odd, or neither. So we're still going to talk about even functions and odd functions where they have opposite inputs. And with even, remember even kind of think same. For instance, if I have 3 and 12, I should also have -3 and 12 being on the same table. Okay. Odd functions, remember all the O's? So we had opposite functions, had opposite inputs and opposite outputs. Okay. So for instance, 312 and -3, -12. Okay. So that's what they mean by opposite inputs, same outputs, and opposite inputs, opposite outputs. And then you can classify the graph as either even or odd or neither. Okay. So it says using the information from above, complete the partial graphs below to create an even function and an odd function. So we're going to go ahead and take a look at these two graphs. They are exactly the same, but just to show you what an even function looks like besides what its table looks like. And so in this one here, I'm going to go ahead and take these coordinates and just jot them down on the side so I can do what I was doing up there. And so one of the coordinates is 0, 0. One of the coordinates looks like it's at 1, 2, 3. 1, 2, 3, 4, 5. And the last coordinate down here is at 1, 2, 3, 4, 5, 6, 7, -2. All right, so because this is even, remember we want opposite inputs, same outputs. Okay, so if we have, I'm going to start with the last one here, 7, -2. Sometimes 0 can be tricky. So we'll talk about that in a second. Let's just get the feel for doing 2 of them, and then we'll do 0, 0. So opposite in. So the opposite of 7 is -7. And same out, so same output of -2. Okay. Opposite input of 3 is -3. Same output as 5. Okay, now we get the feel for those. So opposite of 0, well, there isn't an opposite of 0. So 0 is going to stay 0. There is no such thing as positive 0, -0. So that's what you got to be careful about on a table, too, when you're looking at the table for opposite in and same out. Okay, and then same out. So this would be 0. All right, so 0, 0 actually is a point that does not move, so it stays there. And then I'm just going to graph the other two because they do move. So -3, 1, 2, 3, +5, 1, 2, 3, 4, 5, put right here. And then -7, 1, 2, 3, 4, 5, 6, 7, -2 would be here. And then I'm just going to go ahead and connect them. I do not know if I have a straight edge on this program. I don't think I do. Oh, maybe. Hang on. Let's try this. Nope, that's not it. All right, we'll just do a straight line. Know that I would use a straight edge if I could. And if I could find one on here. So we're going to go ahead and just do the best I can with my straight line. Sorry. All right. And so that is actually what an even function looks like. And you might think of something like from geometry where this graph is now what they would call symmetrical over the y-axis, meaning that the y-axis acts like a line of symmetry for this graph. It cuts it exactly in half. That this point down here would match up with this point here, that this point up here would match up with this point here, and this is on the line of symmetry. Okay, it also looks like a reflection over the y-axis. Some people might say that instead of symmetrical over the y-axis. They might say a reflection over the y-axis. All the same thing. Okay, so we're going to go ahead and do the same thing in the next one, but we're going to create not an even function. We're going to create an odd function using what we know about odd functions. Okay, so again, I'm going to go ahead and copy down those same 3 points. So this point here is still at 0, 0. This point here is still at 3, 5. And this point down here is still at -7. Oh, I'm sorry, +7. +7, -2. And then we're going to use what we know about odd functions. So odd functions, remember, are opposite in, but opposite out. Okay, and so here we go. We're going to start with the last one again. So we want opposite in of 7 is -7, but we also want opposite out. Opposite of -2 is +2. Okay. Opposite in of 3 would be -3. Opposite out of 5 would be -5. Opposite in of 0, again, there is no such thing as -0, so we're just going to keep that as 0. And opposite out of 0, again, no opposite of 0, so we could just say 0. Okay, and then we're going to go ahead and plot those 3 points. So we're going to keep the one at 0, 0. Then we're going to have one at -3, -5, 2, 3, 4, 5. And then -7, 1, 2, 3, 4, 5, 6, 7, +2. And again, I'd use a straight edge if I had one on here. I just don't know if I do. So I'm going to try to do my best with some straight lines. And that's what an odd function would look like. And so in Algebra 2, they call this a reflection. Through the origin. All right, which you did not study in geometry. We didn't do reflections through the origin. But you might also say that it looks like a rotation, capital R, if you remember that, around the origin of 180 degrees, meaning if you turn your paper upside down, it looks like the same graph right side up. All right. In Algebra 2, they call this symmetrical through the origin. Symmetrical through the origin or to the origin. Either one, doesn't matter. And so there's lots of things that you can say that this looks like. Would you pick whichever one makes the most sense to you? Okay, so coming down here, it's to graphically prove or to determine if a function is even or odd. Even functions must be symmetrical over the y-axis, like in the first graph. Odd functions must be symmetrical over the origin, which looks like a rotation around the origin of 180 degrees, or turned upside down is the same right side up. Okay. All right, so there's a couple graphs on the bottom, and we're going to determine now, oops, I don't know why that does that. Let's see if I can move them separately for some reason. Okay, maybe up a little bit more. There we go. Now I can see all my pictures. Okay, so in the first graph, let's take a look at it. We have to determine if it is symmetrical across the y-axis, and I don't believe it is, because if it is, some of these points like here would match up with something down here. If I draw on the y-axis, I don't think that would be a line of symmetry for this graph in part A. However, if I flip my paper over I do think that it would look the same upside down as it does right side up. And so I would think that this one looks very similar to something that we did up there in the second graph, right? Upside down. Yeah, it looks like it would match, right? Everybody see that? This part here would match this part here. Okay, and so because that is a reflection or symmetrical over the origin, we would go ahead and say that this graph is odd. Okay, it's symmetrical through origin. All right, so part B. Part B does not look like I could draw on the y-axis and have that be a line of symmetry. And if I flip my paper over, this graph does not look like the same upside down as it does right side up. And so this graph is going to go ahead and get the neither classification. And I'm just going to go ahead and write a little comment that says not symmetrical over y-axis nor over origin. And that's why I'm going to classify that one as a neither. Okay. Part C. All right, this one I think is a little bit easier to see, but I'm going to go ahead and say that this y-axis looks like a nice line of symmetry, that the graph on the right-hand side of it is doing the same as the graph part on the left-hand side. And so I'm going to go ahead and say that this is an even graph. It's even on both sides of the y-axis. How about that? Okay, so it's symmetrical over the y-axis. Okay, part D. Looking at my graph, this also looks like the last one, where the y-axis seems to be a line of symmetry, that my graph on the right-hand side of the line is doing the same thing as my graph on the left-hand side. And so I'm going to go ahead and call this one even. Okay, it's even on both sides of the y-axis, or we could say that it's symmetrical over y-axis. Okay, next one up. This one does not look like it's symmetrical on the y-axis. It does not look like it's doing the same thing. However, if I turn my paper upside down, I do believe that this part of the graph is doing basically kind of the opposite thing this side is doing. Okay, if you turn it upside down and it looks the same upside down as it does right side up, then this is an odd graph. Okay, it looks like a rotation of 180 degrees. If you turn it upside down, it looks the same right side up. Okay, and therefore this one is going to be odd, and we could say that it's symmetrical over the origin. Or some people will say through the origin, doesn't matter. Okay, all right, last one. And it does not look like I could go ahead and have that be symmetrical over the y-axis. Does not look the same on the left-hand side as does the right side. So it's not even on both sides of the y-axis. And if I turn my paper upside down, I don't believe this looks the same right side up. Okay, and so I'm going to go ahead and say that this is a neither. That it's not symmetrical over y-axis nor over the origin. All right, and so that concludes our notes on that, and I will see you guys on the next day.